All right, this video guide is going to go over page 2 of your nomenclature packet. This one dealt with binary ionic type 2 compounds. So that means that every one of the metals is basically a transition metal. And if you look in the middle of your periodic table there, you will notice that all of these have more than one charge. And so I'm going to go through these and show you how to solve them. All right, this first one, I don't know, maybe this wasn't the best one to do right off the bat. This one's a little tricky though. So the first thing you have to notice, tin, if you look at tin on your table, it has two possible charges. It's either 2 or it's 4. And so at first glance, I think probably a lot of us would probably say, okay, tin goes over here, oxygen goes over here. There's an understood 1 that goes to the oxygen. This 2 goes to tin. You might say, oh, this is tin Roman numeral 2 oxide. Okay, that's actually incorrect. Okay, what you have to remember is anytime you're looking at one of these with a transition, you have to look at the anion and you have to ensure that its charge matches with what its charge should be. If you look at oxygen, it doesn't have multiple charges. It has one charge. It's negative 2. It cannot be negative 1. So what do we have to do? Well, what we do is to make this what it should be is if it's negative 1, you have to double it. Well, if you double 1, you double them both. So this is actually tin Roman numeral 4 oxide. All right. And here's another way to think of it. Here's tin with a 4 plus. Here's oxygen with a 2 minus. Okay, SN and O. This 4 goes down here. This 2 goes over here. But what you notice, 2 and 4, you can simplify. You can reduce them. They're both divisible by 2. And so if you divide them both by 2, that is tin 4 oxide. That 4 is not telling me there's 4 of anything. It doesn't mean there's 4 tin. It doesn't mean there's 4 oxygen. The only thing this Roman numeral 4 states, it is the charge of the metal. So that is tin 4 oxide. Next one, let's unzip this guy. Here's manganese. Here's oxygen. The 2 goes to oxygen, which is oxygen's charge, so that's good. The 7 goes up to manganese. Manganese does have a charge of 7. It's one of the choices. And so you would name this manganese 7, which is VII oxide. Make certain you pay the special attention that there are a couple of elements, manganese and magnesium. Those are two different things. Mn is manganese, Mg is magnesium. So manganese 7 oxide. This guy, Fen, we got to separate the iron and the nitrogen. Notice there is an understood 1 here. There is a 1 here. Okay, you look at it, oh, iron doesn't even have a choice of 1. It's either 2, 3, or 6. Well, if you look at nitrogen, nitrogen's charge is never 1. Nitrogen's charge is 3. So if you triple 1, you must triple them both. This is iron, Roman numeral 3, nitride. Okay, next one, we have Cu3N2. So let's go ahead and unzip this guy. We're going to put the 3. It's going to go over here to nitrogen, which is nitrogen's charge, which means the 2 goes over there to copper. So this is copper, Roman numeral 2, nitride. That's an R. Okay, TiF3, we've got to unzip this guy. Titanium goes over here. Fluorine goes over here. There's an understood 1 that goes to the fluorine, which is fluorine's charge. This 3 goes over the titanium. So titanium, Roman numeral 3, fluoride. Okay, Cu2S, we're going to put copper here and sulfur here. This 2 goes up to the sulfur. Sulfur is 2 minus, so that's good. This 1's going to go over to the copper. So this is copper, Roman numeral 1, sulfide. Okay, this next one, Fe2S3. All right, we're going to put iron over here. Sulfur over here. This number 2 goes to sulfur. If you look at sulfur, that is its charge. This 3 goes over to iron. So this is iron, Roman numeral 3, sulfide. Okay, copper. Copper goes here, bromine goes here. This understood one goes to bromine. This understood one goes to copper. Bromine's charge is 1 minus, so this means that this is copper, Roman numeral 1, bromide. Okay, this one we have CO3N2, so we're going to put cobalt here. Nitrogen goes here. This number 3 goes to the nitrogen, which is nitrogen's charge. This 2 goes to the cobalt. Cobalt, Roman numeral 2, nitride. COF2, we're going to unzip this guy. This understood 1 goes to fluorine, which is fluorine's charge. This 2 goes up to the cobalt. Cobalt, Roman numeral 2, fluoride. Okay, this bottom portion, these are all the names, and so we're writing the formulas. And so copper, well, we look at copper and it's like, well, it's either it's 1 or it's 2. Which one is it? Well, I wonder. Okay, that's what that Roman numeral is there for. It tells us what copper's charge is in this instance. Nitrogen is always 3 minus, and so you just simply swap them. The 3 comes down here, the 1 goes there, and it's understood. So Cu3N is copper 1 nitride. Cobalt 3 fluoride. So cobalt in this instance, its charge is 3 because of that Roman numeral. Fluorine is always 1 minus. This 3 goes down here. This 1 goes over there, so it's COF3. Titanium 4 oxide. That tells me titanium in this instance is 4 plus. Oxygen is always 2 minus. Okay, 4 goes down here. 2 goes down here, but what you recognize, they're both divisible by 2. If you can simplify them, you must simplify them. And so this is going to be TiO2. Has to be simplified. Iron 2 nitride. This tells me iron's charge is 2 plus. Nitrogen's charge is 3 minus. And so what we're going to do, this 2 is going to go here. This 3 is going to go here. And so it's Fe3N2, iron 2 nitride. Iron 3 chloride. This tells me iron's charge is 3 plus. Chlorine is always 1 minus. This 3 goes here. Understood 1 goes there. FeCl3. Copper 2 oxide. This tells me copper's charge is 2 plus. Oxygen is always 2 negative. When you have equal and opposite, they cancel. Okay, or you can think of it this way. If you put a 2 here and a 2 here, since they're both divisible by 2, you must reduce them. But equal and opposite cancel. Copper 2 oxide is CuO. Rhodium 2 oxide, same deal. Rhodium is 2 plus, oxygen is 2 minus. Equal and opposite, they cancel. RHO. Okay, tin 4 sulfide. This tells us in this instance tin is 4 plus. Sulfur is always 2 minus. SN, 2 comes down here. S, so that 2 goes there. And then this 4 goes here. Notice 2 and 4 are both divisible by 2, so you must reduce or simplify. SNS2. Manganese 4 nitride. This tells me that manganese is 4 plus in this instance. Nitrogen is 3 negative. Mn, and you're going to put the 3 here, and 4 goes behind it. There's no way to simplify it. That's the answer. Copper 1 fluoride. This tells me copper is 1 plus in this instance. Fluorine is always 1 minus. 1 plus and 1 minus, equal and opposite. They cancel. CuF. Cobalt 2 sulfide. This tells me cobalt's charge is 2 plus. Sulfur is always 2 minus. 2 plus and 2 minus, equal and opposite. They cancel. COS. Iron 3 oxide. This tells me that iron's charge is 3 plus. Oxygen is always 2 minus. Okay, so this 3 goes here. This 2 goes here. You just cross them. Fe2O3, iron 3 oxide. And that's it.